In this section, we will learn about laws of chemical combination. The first law of chemical combination is law of conservation of mass. It states that matter can neither be created nor be destroyed. So this is law of conservation of mass, which states that matter can neither be created nor be destroyed. This law was put forth by Antony Lavoisier in the year 1789, and this law formed the basis of several later developments in chemistry. So this was the basic law of chemistry, which is the law of conservation of mass, and it states that matter can neither be created nor be destroyed. This law was the result of exact measurement of masses of reactants and products and carefully planned experiments performed by Lavoisier. So this law was formulated after undertaking experiments with exact measurement of masses of reactants and products, and it was found that masses of the reactants were equal to masses of the products in all the chemical reactions. And by noting this, then Lavoisier put forward the law of conservation of mass. After the first law, we have the second law of chemical combination, and this law is law of definite proportions. It states that a given compound always contains exactly the same proportion of element by weight. So this is law of definite proportion. It says that a given compound always contains exactly same proportion of elements by weight. And this law was given by a French chemist by the name of Joseph Proust. It is also referred to as the law of definite composition. The validity of this law has been confirmed by various experiments. So various experiments have been undertaken to confirm the validity of this law. Gaseous water containing 1 part of oxygen and 2 parts of hydrogen. This is law of a definite proportion. So no matter what the source of water is, it will always contain 1 part of oxygen and 2 parts of hydrogen. Along with the law of multiple proportions, the law of definite proportions forms the basis of stoichiometry. So along with the law of multiple proportions, the law of definite proportions forms the basis of stoichiometry. Next, we have the law of multiple proportions. It states that if 2 elements can combine to form more than 1 compound, then masses of one element that combines with fixed mass of the other element are in the ratio of small whole numbers. So this is the law of multiple proportions. It states that if 2 elements can combine to form more than 1 compound, then masses of one element that combined with fixed mass of the other element are in the ratio of small whole numbers. This law was proposed by Dalton in 1803. The law of multiple proportions is one of the fundamental laws of stoichiometry. So the law of multiple proportions, which was proposed by Dalton in 1803, is one of the fundamental laws of stoichiometry. Next, we have Gay-Lussac's law of gaseous volumes. It states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at the same temperature and pressure. So this is Gay-Lussac's law of gaseous volumes. It states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at same temperature and pressure. This law was given by Gay-Lussac in 1808. So this law was put forth by Gay-Lussac in the year of 1808. Next law which we have here is Avogadro's law. It states that equal volumes of gases at the same temperature and pressure should contain equal number of molecules. So this is Avogadro's law, which states that equal volumes of gases at the same temperature and pressure will have equal number of molecules, and this law was put forth by Avogadro in the year of 1811. Avogadro made a distinction between atoms and molecules, which is quite understandable in the present times. So Avogadro was the first one to make the distinction between atoms and molecules, and which is quite understandable in the present time. We know that atom is a single entity, whereas molecules are made up of 2 or more atoms. The next concept which we will learn here is the concept of atomic mass. The mass of an atom is called atomic mass. So atomic mass is nothing but the mass of an atom. Also, 1 atomic mass unit is equal to mass equal to 1/12 of the mass of the carbon-12 atom. Now, AMU is the unit which is used for measuring atomic and molecular masses, and 1 AMU is equal to 1/12 of the carbon-12 atom, and it has been calculated that 1 AMU is equal to 1.66056 into 10 raised to power minus 24 grams. Nowadays, U, which is unified mass, has replaced AMU. So nowadays we are making use of U, which means unified mass, in place of AMU. Also, average atomic mass is equal to mass of the isotope multiplied by the relative abundance. Let us do an example here. The relative abundance of two isotopes of copper having atomic masses 62.93 U and 64.94 U are 69.09% and 30.91% respectively. Calculate the average atomic mass of copper. So here in this example we are given two isotopes of copper with masses 62.93 and 64.94, and relative abundance is given to be 69.09 and 30.91. And we have to calculate the atomic average mass of copper here. Average atomic mass of copper will be 62.93 multiplied by its respective relative abundance, which is 69.09 over 100 plus 64.94 into 30.91 divided by 100, and this comes out as 63.55 units. This is the average atomic mass of copper. After atomic mass, let us see what is the molecular mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. So molecular mass is the sum of atomic masses of the elements present in a molecule, and it is obtained by multiplying the atomic mass of each element by number of its atom and adding them together. Let us see how. Here we have an example. We have to find the molecular mass of carbon dioxide, which will be equal to 1 into atomic mass of carbon plus 2 into atomic mass of oxygen. Now, atomic mass of carbon is 12.011 units. Twice into atomic mass of oxygen is 16.00 units, and when this is calculated, this comes out as 44.011 units. Next, let us see what is formula mass. It is the sum of all the atoms present in a formula unit of a compound. So formula mass is the sum of all the atoms which are present in the formula unit of a compound. It is used in the case of electrovalent compounds. It is used for compounds whose constituent particles are ions. So formula mass is used for compounds which constitute of ions. Example is formula mass of NaCl is atomic mass of sodium plus atomic mass of chlorine. Atomic mass of sodium is 23.0 units and atomic mass of chlorine is 35.5 units. Added together it gives 58.5 units. This is packing of Na plus and Cl minus ions in sodium chloride, and formula mass of sodium chloride is 58.5 units.